Hello. Today we're going to be looking at Chapter 4, Section 3, Distinguishing Among Atoms, and specifically the first learning objective, which is Learning Objective 4.3.1, Explain what makes elements and isotopes different from each other. So really understanding what those terms mean. And we're going to start by looking at this table here, Table 4.2. You can see that it's the first 10 elements, and the headings are symbol, atomic number, protons, neutrons, mass number, and number of electrons. And look and see if you can find which of those are the same for each element. Okay, perhaps you've noticed that atomic number and the number of protons are always the same for a particular element. The other thing that is always the same is the number of electrons. This is true if we're talking about, and we use the word atoms, because when we use the word atoms, we mean neutral, the same number of electrons and protons. So atomic number and the number of protons are identical to each other. The number of neutrons can be the same, or they can be different. And different atoms of the same element can have different number of neutrons. We call those isotopes. That's why you'll see neutrons has an asterisk, and then you see the explanation of that is over there. That these are the number of neutrons in the most abundant isotope. So most hydrogen atoms have 0 neutrons, but there are some hydrogen atoms that have 1 neutron. There are even some hydrogen atoms that have 2 neutrons. So that number of a neutrons, the number of a neutrons is going to vary. And then if you take a look at this column right here, mass number, can you figure out where that number is coming from? If you look at, it's always the sum of the protons and neutrons, right? 3 plus 4 is 7, and 4 plus 5 is 9. That's what mass number is. So let's flip to the next page and start writing out the definitions of these. So the definition of an atomic number is the number of protons in the nucleus of an atom. It also is unique to that element. What makes oxygen oxygen is the fact that it has 8 protons in its nucleus. Right? No other atom will have 8 protons in its nucleus other than oxygen. Even if we take an atom and somehow can change the number of protons in its nucleus, that then changes the identity of that atom to that of a different element. And then mass number, we saw on the previous page, mass number is the sum or the total of protons plus neutrons in a particular isotope of that element. So 2 atoms of the same element would have to have the same number of protons, but they could have differing number of neutrons. There's a little mnemonic that we have to help us remember that. Ape Man, where atomic number is equal to the number of protons and to the number of electrons. Again, if it's something that we're going to call electrically neutral, meaning the same number of protons and electrons, not an ion. And then man, mass number minus the atomic number equals the number of neutrons. One thing that students will oftentimes have some difficulty with is understanding the fact that the mass number is not the number of any one particle, but you can always get the number of neutrons by subtracting the number of protons from the mass number. Okay, now we're going to use these doodle notes to help us get a little bit more information about all the information that is contained in a square on the periodic table, specifically around elements. So the top part here is basically the definition of an element. A substance that cannot be broken down into simpler substances by chemical means. An element is composed of atoms that have the same number of protons in their nucleus. So now if we look at a typical square on a periodic table, you're going to see a number of things inside of that square. You will always see the element's atomic number. You will always see the element's atomic symbol. You may see its name written out, but on some periodic tables they skip the name altogether. And then you will always see the average atomic mass. So let's start by talking about the atomic number. So the atomic number you will always recognize as the whole number, and it will always increase by 1 going from left to right on the periodic table. So what is the atomic number? Well, that is every element has a unique atomic number, right? It indicates the total number of protons in the nucleus of the atom. Normal atoms are electrically neutral. We could say normal atoms or just neutral atoms, or atoms that aren't ions, are electrically neutral, the same number of protons as electrons. So the atomic number for many elements, as long as it's an atom, is also the number of electrons. So for example here, this is magnesium. Magnesium's atomic number is 12, which means I can deduce that it must have 12 protons. And if we're talking about the magnesium atom, not the ion, the magnesium atom will also have 12 electrons. You will also see an element's name sometimes listed on the periodic table. And every element has a unique name. Many element names are very old and are based on other languages. So they give a few examples here. Chlorine is named after chloros, the Greek word for yellowish green, which is the color of what chlorine gas looks like. Newly discovered elements are named by the discoverer. Usually it's not just a discoverer, but now it's also the creator, since we have discovered all of the naturally occurring elements. The new names must be approved by an international committee. Right now we have named elements up till number 118. Even though every element or every square on the periodic table may not have the element's full name, it will always have the element's symbol. And the symbol is what we're going to use for elements when we write them for isotope notation or balanced chemical equations or symbols for chemical formulas. Every element is abbreviated using a unique symbol of 1 or 2 letters. The first symbol is always capitalized. And if there is a second letter, it is always lowercase. That's really important. Some are based on other languages. For example, Fe is iron from the Latin term ferrum. And finally, most squares on the periodic table will also have the average atomic mass. Remember that an element is composed of many different isotopes, and so the number on the periodic table needs to stand for the average mass, combining a weighted average of all of the isotopes. We're going to talk way more about how to mathematically calculate that in another section. So the atomic mass is the mass of the protons and neutrons in an atom. Every proton and neutron has a mass of 1 AMU. Electrons do not count towards the mass because they are tiny. The mass can be shown as a decimal because the average mass of the isotopes of the element. So the reason why the average atomic mass is often a decimal is because there are many isotopes that are present in nature of every atom or of most atoms. So just as if you were to look up how many children does the average family in America have, I believe it's 2.1, when in fact, no family in America has 2.1 children, because how can you have 0.1 children? But if you were to average them, that would be the number that comes out. On the bottom of this, there's 3 questions for you to try. You're going to need to look at a periodic table to answer most of these. And we'll go over the answers next time that we are in class.